we're going to talk about sequences, which I really enjoy because you see a lot of sequences, especially like in real life math. If you've ever taken an IQ test, sequences are usually on an IQ test, like patterns, whether it's like picture patterns or like number patterns. So we're gonna like divide, 87, Selena. We're gonna divide sequences into two categories. One is when you're adding and subtracting something, and then the other one is when we're multiplying by something. What I mean that is to get the next number. So if we look at this sequence, 3, 8, 13, 18, 23. Are we adding or subtracting, or are we multiplying? We're adding. Specifically, we're adding 5. Okay, adding 5. And there's not a question about that yet, but just so we know, we're adding 5. So the ... at the end of the sequence means that this sequence is going to continue on forever. Does anybody know what the ... is called?
It has a name.
Say it, Sarah.
An ellipses.
Ellipses. Yeah, it has a name. Just like a period or a semicolon. It is a part of like speech, I guess. No, that's not right. What are they called? Grammar? What are those things called? Punctuation. Yeah, that was what I was looking for. Ellipses is what it's called. So 3, 8, 13, 18, 23 are called the terms. So if I'm asking about the first term is 3. 8 is the second term. 13 is the third term. 18 is the fourth. 23 is the fifth. 87. Carson, 87. Yeah, we're jumping backwards. So Algebra Nation teaches sequences like separately, and I don't like that, so I teach them together. Hence why we're like jumping backwards. So we're gonna make a couple tables, fill in the missing pieces of a couple tables. So this first table is just talking about the notation. So when I'm talking about the first term, I don't want to use 1 because that could be confused with the actual number. So what we do is we call it A1, first term. A2 is the second term. A3 is the third term. A4 is the fourth term. And for this sequence, the fourth term was 18. A5 is the fifth term, and for this sequence was 23. We can talk about any term, hence this, any number, any term, AN. All that is a notation. It's just because it's confusing by just calling it a number, so they associate that number with an A. That's how we talk about sequences. Now, what would I do if I needed to find the 50th term? Well, I would need to know the 49th term, and I would add 5 to that number. Well, how would I know the 49th term? I would need to know the 48th term. To be able to figure out the 48th term, I would need to know the 47th, and so on. I need to know the number before it to be able to find the next number. For now, in about 5 minutes, it's not going to be the case. But for right now, all you know what to do is to take the number and add 5 as many times as you need to get to that number. So again, this is just purely a notation, okay? Yes?
You can just like multiply 3 times 10 and like so quickly, like
3 times 10.
or like you like subtract 10, like say like you're trying to get to 50, you can like subtract 10 right after, then you get to 40. I don't know how to explain what I'm saying.
Give me 5 minutes and then what you're saying will make sense. Yes, you're getting there. You're gonna do something with the 5s. Yes, multiples of 5. Don't tell me what you think it is right now. Is that what you're gonna say?
I'm gonna say.
Don't tell me what you think it is. Okay. So for us to find any number, again, I can't say this enough. This is just notation. So this is what's going in that box. I just have big handwriting, so I can't fit it in there. A(n minus 1). That notation is just talking about the previous number. So if we're finding the 50th term, what would be the previous term? The 49th. 50 minus 1. If we're looking for the 1000th term, We would 999th term, which would be 1,000 minus 1. That's all that's talking about. So for us to find any number, we're going to take the previous number and we're going to add 5 for this sequence. That's not obviously going to be true for every single sequence, but for this one, all this notation is meaning is the previous number. That's all that's saying. I know it looks complicated, but the terminology to use is the previous number. We could also use function notation. So f of 1 is the first term. F of 2 would obviously be the second term. F of 3 represents the third term. F of 4 would be the fourth term. F of 5 would be the fifth term. And then F of n would be the nth. It's funny, nth term. Oh, and I skipped something over here. I'm going to jump back real quick to this. Does anybody know what that A word says? Okay, it does say arithmetic. So like live and live, like those two words, live and live. You know how you like change the pronunciation based on like how you're using it? Same with this word. It doesn't say arithmetic. It says arithmetic. And so it's not arithmetic sequence, it's arithmetic sequence because of the context we're using it in. So that's when you take the sum of a number and the number before it. That's all we're doing. We have a set of numbers, and to find the number, we are taking it and adding 5 in this case to it. We could be subtracting something as well. So arithmetic, everybody say it. Arithmetic, not arithmetic. But again, it's just same spelling, different pronunciation. What is that called? A homophone, homonym, one of those things. Y'all ever? I don't remember what they're called. Go ask Mr. Stitt or whoever you have for language arts. They would know. Okay, so we're going to fill in this table. So we're going to try and find the 9th term. So we know that the first term is 3. To find the second term, 8, we would add 3 plus 5. To find the third term, you take 13. To get 13, you would take 8 plus 5. To find the fourth term of 18, you would do 13 plus 5. To find the fifth term, you would do 18, which is the previous term plus 5. So go ahead and fill in 6, 7, 8, and 9. That's the process we have to go through to find the 9th term. All right, for the 6th term, you should have gotten 28, and we get that by adding 23 plus 5. For the 7th term, we got 33, which is 28 plus 5. And then 38, which is 33 plus 5. So then the 9th term would be 43, which we got from adding 38 plus 5. So not bad when we're talking about the 9th term. So this is called finding the sequence recursively, using the recursive formula. Recursive just means that we're jumping back to the number before it to find the next number. So the way to write that is AN. So to find any number, we're going to use the previous number. Remember, we note that by saying AN minus 1. So how I would read that so far is any number is equal to the previous number plus 5. That would be the recursive formula, or this part is always going to be the same for recursive. The only thing that's going to change for recursive is that. What are you adding? What are you subtracting? And then when we talk about multiplying, what are you multiplying? So recursive doesn't change. So when would this process take a long time? So getting to the 9th term wasn't that bad. 50. I don't care. 1,000, 1,000,000, right? Those would take a long time. You want to sit there and add 5 a million times? No, me either. So when the terms get larger, this process would take a very long time. So the recursive formula is only useful when we're talking about a small number of terms. So like 9, 10, 11. But when we start getting into the 50s, 100s, 500s, there's a separate way to figure this out. So Robert, you can speak now. What do you think?
I was gonna say that is the previous term multiplied by 5 plus 3.
Okay, so yes, I'm going to kind of wrap that up in a little bit of a different word, but look at the next table. Now, instead of using the previous term, we're going to base everything on 3, which is the first number, okay? So to find 8, how many 5s are we adding to 8? 1. For our third term of 13, how many 5s are we adding, adding to 3? How many 5s are we adding to 3? 2. To find 18, how many 5s do we add to 3? 3. To find 23, we add 4 5s. To get to 28, we add 5 5s. Then we add 6 5s. Then 7 5s. Then 8 5s. So when you learned how to multiply, I hope that your teacher referred to it as repeated addition. So multiplication is just adding the same number multiple times. So if you look over here, we took 3 and we added 5 times 1, 1 5. For the third term, we added 5 times 2. For the fourth term, we added 5 times 3, then 5 times 4, then 5 times 5, then 5 times 6. For the eighth term, we would take 3 and add 5 times 7. For the ninth term, we would add 5 times 8. Yes.
So if we're trying to find the 50th, we have to do 3 plus 5 times 49.
Yes, exactly. So every time, which is what Robert said, you're going to take 5, but you're going to multiply it by the previous number. So in this case, when we were trying to find 50, we would multiply it by 49. And the reason is we're starting at 3, which is number 1. How many more numbers do we need to get to the 50th term? We need 49 more numbers. Selena, I just don't know what you're referring to on that one. Can you clarify a little bit for me? So there's a formula that we can use for any sequence, and it looks like this. So any number, again, any number. We're going to use the first number. Everything for explicit, it's called explicit. So before is recursive, this is explicit. We're going to use the first number. Oh, yes, I agree. We're going to add whatever we call this D for common difference. Whatever number we're adding every time, that's what number is going to go there. And we're going to multiply it by the previous number. So I note that as n minus 1. So for example, if I'm finding the 500th term, I would multiply by 500 minus 1, which is 499. So let's make a formula for this specific sequence. So for this sequence, what is the first term? 3 plus 5, and then we have n minus 1. So 3 was the first one, 5 was whatever I'm adding each time. It could be minus 5. That would happen if I was subtracting 5 each time. This one just happens to be adding, okay? You good? Okay, so we're going to find 2 different terms. I want you to find the 60th term, A60, and it's just notating what number term, Nihal. So in this case, we're trying to find 60. And I want you to find 700. So that means for 60, we would be taking 3 plus 5 times what's one number less than 60? 59. For 700, what's one number less than 700? 699. So I'll give you a second to term and the 700th term. Nihal, make sure that you are, make sure you're adding 3 and make sure that you are doing order of operations. I'm not sure that you did that part. So multiply first, then add the 3 at the end. All right, so for the 60th term, yeah, those are right. 5 times 59 is 295, and then you have to add 3. So for the 60th term, you should have gotten 298. And then for the 700th term, excuse me, 699 times 5 plus 3 would be 3,498. A quick one for this sequence, what does it have to end in? Your answer? 8 or 3. Yeah, look, all of those ended in 8 or 3. So if you got something like 645, I at least know that's, I did something wrong. So just make sure that you see the pattern there so that you know it has to end in an 8 or a 3. Yeah, Henry.
And it was multiplying, wouldn't you like 3 times 5 is 50 and then multiply by the prime?
If it, when we get to multiplying sequences,
Yeah.
no, we're actually going to use it as an exponent. And we'll talk about that. We're going to get to that after lunch. But yeah, we're going to use it as an exponent. So like the 50, if I was trying to find the 60th, it would be like 5 to the 60th power instead of just multiply. Yeah. Okay, so let's look at a couple examples. So here's a sequence, 10, 4, -2, -8. So before we do anything, what is happening? -6. 10 minus 6 is 4. 4 minus 6 is -2. -2 minus 6 is -8. So for recursive, remember it's the exact same every time. The only thing that changes is at the end, I got to explain what's happening. And in this case, I'm subtracting 6. So to find any number, I have to take the previous number and subtract 6 from it. And then explicit is based on the first number. So what is the first number? 10. Then we have to talk about how it's changing. It's changing by subtracting 6, and we would multiply that by the previous number, which we show as n-1. So if we are looking for the 42nd term, A42, we would have 10 minus 6 times, what's one number before 42? 41. So go ahead and calculate what the 42nd term would be. If 6 or 6 times 41 would give us -246, and 10 minus 246 would be -236. That would be the 42nd term of the sequence. Okay, I'm gonna have you do number 2, all parts. Make sure that you write the formula, especially explicit. I've had a handful of people mix up the 2 things for explicit, so just pay close attention to that, and let me know when you're done. Digital students, you can just send me your answer to letter D when you get it, so you don't have to type all that stuff, but do all parts of number 2. Let me know when you're done. Okay, so what was happening every time? Add 10. So we went from 7 to 17 to 27 to 37. So the next 3 terms would be 47, 57, and 67. So if you're writing a recursive formula, that is going to be the same, except we would write plus 10 every time. For some reason, I don't know what the miscommunication was. A lot of people put plus 7. The recursive formula has nothing to do with the first number. It just deals with the difference. And then the explicit formula would have been our first number, which was 7, plus 10 times n-1. So that would be the explicit formula. And then to find the 33rd term, we're gonna take 7 plus 10 times 32, because we want one less. So 320 plus 7 would give us an answer of 327, would be the 33rd term. Okay, so let's do one of the beat the test, and then we'll take a little bit of a break. So Johanna is conditioning all summer to prepare for her high school's varsity soccer team tryouts. She is incorporating walking planks into her daily training plan. Every day, she will complete 4 more walking planks than the day before. She starts with 5 walking planks on her first day. So we're just gonna write a couple of the terms. So her first time, she did 5 of them. So how many would she have done the next day? 9, because she's doing 4 more then. Then how many? 13, and so on, okay? So then it says, write an explicit formula. So explicit is the one that we use the first number. So AN, so any number. So what was her first amount of planks? 5 plus, she's adding 4 every day, times n minus 1. So part B is asking how many is she going to do on the 12th day? So we're looking for A12. So 5 plus 4 times 11. Yes, Madison.
49.
49, because 4 times 11 would be 44. 44 plus 5 would give us 49 planks. Hope everybody had a great lunch. What, Henry?
It sounds like a doorbell.
It is like a doorbell. What does that mean?
So Rickroll is just like playing Never Gonna Give You Up by Recursively, and it became this whole trend to see if you could get somebody to click the link and surprise them with like Never Gonna Give You Up. So you could be like, hey, look at this cool meme, and then your friend would click it.
And then it's that song.
Recursively.
Interesting.
Yeah, they played it during lunch.
Sounds like something that Coach Hosford would do.
It was Mr. Weatherington.
Or him too. Okay, so before lunch, we talked about arithmetic sequences. This is page, what did I say? 175? Page 175. So that's if you're adding or subtracting something. So if you're multiplying, technically dividing, but when we're talking about dividing, like if you were dividing by 2, we would refer to it as like multiplying by a half. So we only talk about multiplication. If it's dividing, multiply by a fraction. So our sequence for this one is 3, 6, 12, 24. So what are we multiplying by? Multiply by 2. So if you're multiplying, it's called a geometric sequence. So adding and subtracting is arithmetic, multiplying is geometric. And that's when you take the numbers and you're talking about the product of the previous number and some number here. So the ratio, the common ratio between this would be 2. And just like arithmetic, we're going to talk about the 2 different formulas. The name of the terms is still the same. A1 is still the first term, A2 second term, and so on. So a to the n, if we're talking about the recursive formula, it's still an minus 1, except we're going to be multiplying, in this case, by 2, or multiplying by whatever number that is. And this goes in here. Again, I just have too large of handwriting to fit it in there. So when we're looking for a number with geometric, the recursive process is the same. It's still depending on the number before. So f of 2 is the second term, f of 3 is still the third, f of 4 is the fourth, f of 5 is the fifth, and then f of n is the nth, meaning any term that we want to find, we could find. So for the first part of this, we're going to be looking for the 10th term. So we know 1, 2, 3, 4, and 5, 3, 6, 12, 24, 48. So we're going to look recursively first, meaning basing it on the previous answer. I want you to look at that table and I want you to find the 9th and then find the 10th. So this, it goes 3, 6, 12, 24, 48, 96, 192, 384. So I want you to try and find the 9th and then the 10th term. So we can find the 9th term by taking 384 and multiplying it by 2, which is 768. Did I do that right? Okay. And then for the 10th term, 768 times 2 is 1536.
Yeah.
So again, useful when I'm talking about like a small number of terms. So recursive, remember, is a to the n, so any number. We take the previous number and then multiply by whatever r is. In this case, the r common ratio was 2. We could be multiplying by 10 or 15 or a half. So that's how we would write the recursive process. So let's talk about the explicit one. So the one that we can use to find any number super easy. So here, look at this second table. And we're just going to base everything off the first term. So to find 6, we multiply 3 by 2 one time. To find 12, we multiply 3 by 2 two times. You can also rewrite 2 times 2 as 2 to the second power. To find the fourth term, we multiply by 2 3 times. We could rewrite that as 2 to the third power. Times. To find the sixth term, we use it 5, and then 6, and then 7. So if we're trying to find the 9th term, we're still going to use the first term, which is 3. And then what would our exponent be on the 2? 2 to the 8th power. And let me remind you from last week how to do that in your calculator. So you're going to do 2 to the 8th first. So 2, and then if you hit the exponent button, that one above the C, and then type your 8, you should get 256. And then you want to multiply that number by 3 to get 768. So then if we're trying to find the 10th term, what exponent do we want to use? The 9th power. So 2 to the 9th should give you 512, and then multiply by 3 to get, again, 1,500, excuse me, 36. So the formulas look almost identical as it did with arithmetic. So for geometric, we still have AN. We're still going to use the first term, so A1. But instead of adding or subtracting something, what are we doing? Multiplying. So we're multiplying by some common ratio. In this case, for this problem, it was 2. And the n-1 is now going to be the exponent. So instead of it multiplying in parentheses, it's now going to be our exponent. So if we're talking about this problem, to find any number, we're going to use the first number, which was 3, times my common ratio, which was 2, to the exponent n-1. So they look similar, except obviously the adding and subtracting is now multiplying, and the n-1 is now an exponent. We're not going to use this graph or anything, so you can write underneath it. We're going to find the 17th term, and then we're going to find the 25th term. So if we're finding the 17th term, we would do 3 times 2 to what exponent? 16th. If we're finding the 25th term, we would do 3 times 2 to the 24th. So go ahead and try and calculate those 2 answers. You don't need to show me on these. I'll look at a different one. But all right, for the 17th, 2 to the 16th power times 3 should have gotten 196,608 as the first one. And then for the 25th term, 2 to the 24th times 3, is that 50 million or 5 million? 50 million? 50,331,648. So notice how geometric increases really rapidly, because if we were to graph this, it would look like that, because it's an exponent, right? And when it's an exponent, it's exponential. All right, let's look at we'll look at the beat the test too, and then we're gonna play a game after that. So this sequence says -2, 4, -8, 16. What are we multiplying by? -2. So if we're writing recursive, AN equals the previous number times -2. And then for explicit, our first number is -2 times my ratio, which just coincidentally is also -2. And then my exponent is going to be n-1. So we're looking for the 12th term. So for us to find A12, we're going to raise -2 to the 11th power. So go ahead and calculate what that would be. -2 to the 11th is -2048. And then -2048 times -2 is positive 4096. Anybody ever played the game like 2048 before? Yeah, it's because it's multiples of 2. Squares of 2. So you start with like 2 and 2, 4, 8, 16, 32, 64, 128, and so on. So 2048 and 4096, if you can get that far in the game, are tiles that you'll get to. Okay, so I want you to try number 2. And I do want to see your answers to number 2 when you're done. So you're writing recursive, explicit, and then finding the 20th term. We're multiplying by 2. So for any number, we can take the previous number and times by 2. And explicit, for any number, we're going to start with 7 and multiply times 2 to the n-1 power. Yes, Selena, and I will tell you 99.99% of the time, people use the explicit formula and not the recursive formula. Again, recursive is just easier if you're talking about like a small term number, like 9 or 10. You can just like multiply by 2 a few times. But if you're trying to talk about like the 100th or 200th term, multiplying by 2 that many times would be a lot. So if we're looking for the 20th term, we would do 7 times 2 to the 19th power, which is 3,670,016. Okay. Before we do beat the test, a lot of official, like standardized test questions give you extra information for no reason. So there is one piece of extra information that is not used at all in any 3 parts of answering this question. What is it, Trey?
Enlarged 10 times.
Right, enlarged 10 times. We do not even use that. Now it could ask, how big would it be if it was enlarged 10 times, but it doesn't. All it asks is, what's the first term? What's the recursive formula? What is the explicit formula? So it says an art gallery was showcasing a 6-inch long photo of a geometric landscape. The picture was enlarged 10 times, each time by 125% of the previous picture. So how big was it originally? What's our first size? 6. Yeah, 6 inches or 6. Now, before we make a formula, it is not times 125. Amelia. 1.25. When we talked about growth and decay, remember you had to change the percent to a decimal. 125% is the same thing as 1.25 when we're talking about decimals. So that's why we want to multiply by 1.25, not 125. That would be 12,500% if we're talking about times 125. Then the explicit formula, we're going to have 6 times 1.25 to the n minus 1 power.